Hello everyone, I'm Wenyu. Today, I will be sharing my final year project, an innovative sensor-based ElderCare application involving 3D reconstruction and behavior analysis. The project is done as a group work involving 3 members, with each of us having our own individual focus. We have also participated in the Microsoft Imagine Cup competition. Imagine Cup is a competition that encourages students to develop their original concepts to tackle specific local or global issue in one of the 4 categories: lifestyle, education, environment, and health. We have successfully made it to the Asia regional final and became the lifestyle category winner. So what has motivated us to work on such a project as a group? In today's rapidly aging society, it is found that a significant number of elderly is living alone, without their family members being able to take care of them. Living alone is often associated with higher chance of getting illness and depressive symptoms. Feeling a need to address this pressing issue, we have decided to create a solution that could help all families with an elder relative living alone. This solution involves a mobile phone application, as well as a variety of sensors to be placed at the elder's home, so that user, which is usually the caregiver, could know the health status of their loved ones even when they're away from them. User could simply start by logging to the application and follow the instruction to scan the elder's home by taking videos of each room. It will be processed by a segmentation model and sensor placement optimization model, which are done by my teammates to identify key furniture and generate a customized set of sensor types and locations for the user. After purchase and installation of sensors at elder's home, data will be collected and analyzed to understand the life pattern of the elderly. Weekly health report will be presented to the user to help them better understand the health status of the elder and potential health risks. For the rest of the presentation, I will be explaining my individual focus, 3D reconstruction from video and behavior analysis. Firstly, to talk about 3D reconstruction, users simply need to open the app and turn on the camera to scan the entire room. The video taken will be split to multiple frames based on a fixed time interval. These frames will then be put in the molecular depth estimation model to obtain the depth information. The model I use here is Global Local Path Networks, pre-trained on the NYU depth dataset, a popular benchmark. After obtaining the depth information, 3D point cloud could be created from the color image and depth image using Python library Open3D. With multiple point clouds created, the next step is to combine them into a single one. In order to do this, multi-way registration, a technique to align and merge point clouds, is adopted here. The logic is very simple. The initial alignment process will be carried out to align the points in one point cloud to another point cloud. This process will run iteratively to minimize the alignment error between points. And it is being optimized by a technique called iterative closest point. The final merged point cloud will be obtained after all the alignments. Post-processing, such as denoising, will be performed to improve the results obtained. After all the above steps, a final point cloud will be obtained as the output. This model will be used as the input in my teammates' project to get segmentized and generate sensor placement recommendations. With a recommended list of sensors to the user could simply purchase and install the sensors at elder's house with the instructions given in the application. After collecting data for a period of time, this data will be used for behavior analysis. In order to work on this part, I have installed 7 sensors in my room for training purpose. In total, there are 3 rooms and 3 types of sensors involved, as shown in this image here. I will quickly go through the function of each sensor: PIR motion sensor to detect human motion, pressure sensor to measure the change in mechanical pressure, and contact sensor to detect the opening and closing of doors. This is a brief summary of the behavior data I have collected over 10 days after pre-processing. All the data are being manually labeled with 2 types of labels: location and behavior. As the actual data collected from elderly does not include location label or behavior label, my approach is to obtain a basic pre-trained model using the currently available label data. The sensor output data are being used as the inputs in supervised machine learning methods to predict the location label first, and then the location label will be a new feature to predict the behavior, as many behaviors are closely associated with locations at home. The final outputs from the behavior analysis model will be stored in the database and will be queried to display health reports in the homepage and statistic page. As shown by the two screenshots here, the homepage displays the current status of the elderly and some of the key health status highlights, while the statistics page shows a weekly report using various charts. Although we are able to win a prize in the Imagine Cup, there is still a lot to be done to improve this system. Firstly, we would like to conduct pilot tests with more sensors. Secondly, we look forward to integrate with wearable devices so that more vital sign data could be collected for more accurate prediction, and allow us to provide better emergency detection and handling. Last but not least, developing the reinforcement learning on behavior analysis model to better cater to each unique individual. We hope to bring this application in real life one day so that it could make a difference to all the families with an elder living alone. This is the end of my presentation. Thank you for listening.